In this little video, we're going to be talking about prime factorization. That means taking a number and breaking it apart into a string of factors that are all prime. And you might not understand exactly why that's going to be helpful, but let me tell you that whenever I'm doing a difficult kin, I am crazy about breaking a number into its prime parts. And you will see how that will be helpful when we start working with fractions a little bit more. So let's talk about prime factorization and how to do it. Let's just start with the number 24. If we were trying to find all the prime factors of 24, the way we would start is thinking about two numbers that multiply together to give us that 24. And it doesn't actually matter which ones you start with. Some of you might be thinking about 6 times 4, 8 times 3, 12 times 2. All of those are going to get us to the same end result. So don't stress out too much about that part. I'm going to just pick 8 times 3. Now, whenever you identify a prime number, you want to lasso it off so you know you are done. 3 is prime, so I'm going to circle it up and stop with that one. Let's go over to that 8. See if we can think about breaking it apart a little bit more. Now, some kids are going to make this mistake. They're going to put a 4 and a 4. But 4 times 4 does not give 8. So be really careful here that you're thinking about multiplication. Sometimes I tell kids when we're making what's called a factor tree, you might put little ornaments on your tree, little multiplication symbols, so you remember that we are talking about what number times a number gives you whatever number it is you're breaking apart. So for example, 4 times 2 gives me 8. 2 is prime, so I can rope it off. Finally, I need to break this 4 apart because he is still composite. When I break this 4 apart, I'm going to end up with 2 times 2. And once I end up at a dead end with no more numbers to break apart, I know I have found the prime factorization of this number. It is 3 times 2 times 2 times 2, or a number sentence that looks kind of like this. Some of you might be ready for a little 6th grade action where you would show this exact equation like this. 2 to the power of 3. If you're not ready for that, don't worry, it's okay. Let's try another prime factorization to see if you are getting the swing of it. Let's do the prime factorization of the number 50. If I want to break that 50 apart, I'm going to break it apart into any two numbers that multiply together to get 50. So in this case, I'm just going to start with the first one that comes to my mind, which is 5 times 10. One of those is prime. Hopefully you know which one it is. It's this guy. So I lasso him off, and I'm free to carry on breaking apart this number 10 until I end up with only prime numbers. What two numbers multiply together to give me 10? That would be a 5 and a 2. And now that all my numbers are lassoed off, I know that I'm done. Let's look at this one more time with a different strategy. Let's say that you are a kiddo that instead of breaking it up 5 and 10, you broke it up 25 times 2. 2 is prime, so I lasso them off. Let's break that 25 apart. 5 times 5, I lasso them off. Notice, you guys, that we ended up with the exact same digits. 5 times 5 times 2, or 5 times 5 times 2. So it's pretty cool that you don't have to do it the exact same way as your neighbor, but if you are truly breaking a number up into its prime factors, you will end up arriving at the same place, no matter if you do it in a different way. Now, this is a perfect place to talk to you about a mistake that might seem kind of silly, but it is a mistake that I see kids make a lot. And it goes something like this. They see the number that they're trying to break into the prime factors, and instead of actually breaking it apart, they will actually do something like this. 50 times 1 gives 50, which is true. But 1 is not prime or a composite, so it doesn't really help us break that number apart. Then they will take this number and they will break it apart again. 50 times 1. 1 is not prime or composite. So then they will continue to break it apart. And I'm telling you, this system could go on forever and ever and ever. So the big rule is, don't worry about breaking a number apart with a factor of 1, because 1 doesn't really help you break that number down into smaller factor parts, if that makes sense. So let's leave the 1s out. They don't need to play in this little game. We are going to break it apart in any other way with any other factors that we can think of. And if that happens, you will end up finding the prime factorization of a number.